right, so here is the sample calculations for the order of reactions. Okay, it's going to be a lot of calculations, so just hang in there. It's going to be all okay. All right, as soon as you kind of get into it. So anyhow, so some of the volumes you're going to use are already given to you. So you're using 5 milliliters of this, and potassium permanganate is 1, and water is 6. The concentrations are also given to you. So the concentration here is for oxalic acid is 0.755, and for permanganate it is 0.13. Okay, so this is already, it's given to you, but now that you're mixing everything up in more water, you need to calculate new concentrations. Okay, so for oxalic acid, for example, it's going to be 5 divided by 12, which is 5 plus 1 plus 6. That's a total of 12 milliliter. So dividing it by 12 times the concentration, 0.755, and this is equal to 0.3146. Okay, I've already done the calculation, so I'm going a little fast, but you will have to do this on your own while I'm doing this one. So you'll have to do for 2 and 3 on your own, okay? So that's how you calculate the concentration for oxalic acid. For permanganate, it's the same thing, which is now 1 over 12, because the total volume is still 12, but now the concentration is 0.130, and then this is equal to 0.01083. So that's the concentration for all of these, because you're using the same amount. Okay, so you don't have a trial 4, so that's fine. Okay, you only have 3 trials. This is an old report sheet that I'm using, but anyhow, so those are your concentrations you're going to use for your further calculation. So remember, you're trying to see the disappearance of the color of potassium permanganate. Okay, that's the thing. So the time here could be anything from 170 seconds to, I don't know, whatever you get, 300 seconds. That's dependent on you and how much time you get, okay? But anyhow, the calculation for the concentrations is going to be this way for trials 1, 2, 3, all right? And then you can go ahead to the next page, because now you need to use these concentrations and times to calculate the rate of reaction. So remember here, we just calculated 0.3146. And this was 0.01082, okay? And so then your average time, so what you're going to do is, of course, you will have all of these times for 3 trials, and you're going to take the average of that. And I'm just going to go ahead and presume 200 seconds, okay, for just the sake of calculation. So let's say you had a 200-second average over here. So then the rate is going to be the rate of disappearance of KMNO4. So that's 0.01082 divided by 200. And so then this is equal to 4.92 times 10 to the negative 5 moles per second, molarity per second, right? That's how it's going to be. So then you're going to do all the other calculations as well, depending on your concentration. So once you have this, remember, you're going to do 2 and 3 from here as well, right? So 2, you're going to have a different volume that you're using. So you're using 10 here, and 5 here, 1, and then 2 and 5 here. So you have all these different, but the total is still 12, right? 12 milliliters. So then you're going to do the concentration calculations for trial number 2 and 3. So those are the values you're going to put over here, and then you'll do the average time here, calculate the rate of reaction. So once you have the rate of reaction, okay, you will see that, and let me show you. I don't want to make you dizzy by scrolling up and down, is you will see that you will have the same calculation or the same concentration for oxalic acid for trial number 1 and trial number 3, because they have the same volumes. And then you will have for trial number 1 and 2, the same concentration for potassium permanganate, okay? Because you need to change 1 and keep the other constant. Okay, that's what we are trying to do here. So for oxalic acid, it's going to be trials experiment 1 and 3. For permanganate, it is experiment 1 and 2. Okay, so now that when you do your calculations for the third part, which is the order of reaction. So you have to find the rates, okay? Over here also, you'll have to find the rates of reactions. So once you have done that, you will do it as we do it in class, which is experiment, depending on what things you are studying, experiment over experiment. So in this case, for you guys, it's going to be experiment, 2/1 for oxalic acid, because you're changing the concentration of oxalic acid, and experiment 3/1. You can do it the other way, experiment 1/3. I like to have my large numbers up, and by large numbers, I mean what's going to come on the rate of reaction, okay? Because remember, what is coming here is you're changing the concentration and you're comparing it to the rate. Okay, so that's kind of what you're doing. So experiment 2, okay, so for experiment 2, what was the concentration of oxalic acid? And so you would have changed the concentration for oxalic acid, and the rate would have also changed, right? So for experiment 2, what is it? For experiment 1, what is it? Okay, so the same thing here for 2 and 1. And so then you look at the numbers that come out. So, maybe you get 3 and then you get 3 here. So if you're changing the concentration by 3 and your rate also changes by 3, that's a first order. Okay, that could happen for 2 and 2 also, right? Because that didn't change. So if you double the concentration and you double the rate also, then that is first order, all right? So then you will do the same thing here for experiment 3/1, because now this is with respect to potassium permanganate. And so then you will find your rates, your concentrations, and then the rate, okay, that you have. This is the way I calculate. If your professor is doing it a little bit different way, that's fine too, okay? It's not anything different. You'll still get the same results, okay? So this is just the way I do it, and I find, of course, my way a lot easier. So that's why I do it this way, okay? And again, if you get 2 and 2 here, that means it's a first order, okay? So if it's first order, then your rate equation is then K is equal to then oxalate, which is C2O4, or you can just write oxalic acid, and then permanganate, KMnO4. You don't have to write 1 and 1 because it's understood, but you can go ahead and write 1 and 1. If they come out to be 2 and 1, then you write 2 and 1, okay? And then calculate for K, all right? So you can do that from your rate equation. And so I have one small error. This should be all together, okay? Because it is rate is equal to K. K is the reaction constant, right? So the rate constant, that's what it is. So you calculate K by taking any set of values, okay? So you take either experiment 1, 2, or 3, just make sure you're consistent, okay? So remember, this is going to be rate over oxalic acid and then KMnO4, right? So you either take all of experiment 1 or experiment 2. It doesn't matter which one you take, you should get the same answer. That's the whole point of K, is that it's going to be constant, okay, for that reaction. So that's how you will do the first part of this reaction. The second part of the experiment is very simple, so I don't have the calculations here for you, the effect of temperature, because you have the concentrations already calculated, which is, over here. So you've done the calculation for concentrations, and then all you have to do is how the rate will change according to the temperature, okay? Because the time is going to change. So if the time is changing, then you have a new rate, okay? That's all you have to do for that. This one was a little bit more involved, so I thought I'll show you. So I hope that's clear. Let me know if you have any questions, and that's that.